This video is for my Florida students who are preparing to take their Algebra 1 end of course exam. So I'm going to go through the first 10 questions of this practice exam that is provided online. I'm going to put the link to the practice exam in the description of the video so that if you want to try it on your own first and then come back here and see how you did, you can do that. All right, so let's get started. Number 1 says Sandy and Felipe are participating in a walk for life to raise money for charity. Sandy will raise $30 plus $2.50 for each mile she walks. Felipe will raise $20 plus $5 for each mile he walks. The total amount that each will raise can be calculated using the following expressions, where N stands for the number of miles walked. So we can see the verbal description here in the expressions, where it shows that Sandy makes $30 plus an additional $2.50 for each mile she walks. That's why we're multiplying the $2.50 times the number of miles she walks. Same thing with Felipe. He's raising $20 plus an additional $5 for every mile he walks. So we're multiplying each mile he walks by 5. And the question is, after how many miles will Sandy and Felipe have raised the same amount of money? In math, the same translates to equal. They're basically just asking us, when are these two expressions going to be equal to each other? So we're going to write an equation. Two things that are equal to each other make an equation. Once you've written your equation, you're halfway there. Now all we have to do is actually solve it. So when I solve an equation that has variables on both sides, the first thing that I like to do is get the variable to one side. So I'm going to do that by subtracting 2.5n from the left side and from the right side. And of course, I have to do it to the 5n because they are like terms. I can't subtract it from the 20. On the left side, I'm going to bring down that 30. These will cancel out because they equal 0. I'm going to bring down my equal sign and my 20. And then I'm going to subtract 5n minus 2.5n is positive 2.5n. All right, we're solving equations, which means you're trying to get the variable by itself, which means I have to get rid of that 2.5 and the 20. It's easier to get rid of addition or subtraction first. So I'm going to get rid of that constant. It's easier to get rid of the number that's on its own first. If I subtract 20, that will get rid of it because 20 minus 20 is 0. But of course, whatever I do on the right, I have to do on the left as well. So 30 minus 20 equals 10. Bring down that equal sign and bring down that 2.5n that's still on the right side. Now, the only number I have left to get rid of is that 2.5. It's being multiplied by n, so I'm going to do the opposite or the inverse operation, which is to divide by 2.5. Why? Because if I divide 2.5 by 2.5, I'm going to get 1. And 1 times n is just n. Now, again, whatever I do to the right, I have to do to the left as well. So I'm dividing by 2.5 on the left to give me 4. And from the problem, it tells us that n represents the number of miles. So I can read this as the number of miles is 4. And I see that that is answer choice B. Now, if you want a different way to do it, you can always use your answer choices and just substitute them into these two expressions that you were given, because we're just trying to see when are those two expressions going to be equal. So if I took the number 4 and I substituted it into Sandy's expression, so instead of writing n, I'm writing 4. I multiply this, I get 10 plus 30 equals 40. What does this mean? This means that she will have raised $40 after walking 4 miles. Now I want to know, will the same thing happen with Felipe? So come with me to the right side of the screen. I'm going to take Felipe's expression, 20 plus 5n, and I'm going to replace his n with 4 as well to see what happens when Felipe walks 4 miles. Remember, the n is miles. Well, 4 times 5 will give me 20, and 20 plus 20 is 40, and that is the same amount of money that Sandy would have raised after 4 miles. So that's another way to do it. You could just take the answer choices, substitute them in, and see which one will give you a true statement. Number 2, Akeem weighs 140 pounds and hopes to add weight in order to play football in the fall. He hopes to gain between 0.5 and 1 pound per week over the next 10 weeks. Akeem will record his progress on the graph below. On the graph, the solid line represents a weight gain of exactly 1 pound per week. The dotted line represents a weight gain of exactly 0.5 pounds per week. If Akeem gains more than 1 pound per week, which region on the graph will contain all possible points that could represent Akeem's weight gain progress? So they're asking us, are the points that represent more than 1 pound of gain per week in this region, region C, are they points that are here in region B, or are they points that are at the bottom in region A? Where are the points that show that he's gaining more than 1 pound per week? All right, when we talk about his weight gain progress, that is talking about his rate of change. And the rate of change is the same thing as the slope of a line. Now, what you'll notice is that the line that represents the 0.5 pounds per week weight gain is less steep than the line that represents the 1 pound per week weight gain. So the higher the slope of a line, the steeper that line is. So if we want to look for points that would be on a line that represents more than 1 pound per week, that means that we're looking for an even steeper line than the 1 pound per week line. So that means I'd be looking for lines that look like this red one or this red one. These are all lines that are steeper than the 1 pound per week. That means that all of those would be weight gains of more than 1 pound per week. So you can see that all the lines I drew were going to be in region C. So that is the answer. We can, again, in math, you can always do things more than one way. So if I took a point in region C, let's say I took the point right here, that's 3, 149. Well, he started at 140 pounds. So if he's 149 pounds now, that means that there was a 9-pound gain. And if he's gaining 9 pounds in 3 weeks, that means that he gained 9 divided by 3 pounds per week. And that would be the more than 1 pound, which is exactly what we wanted. So region C is the correct answer there. Lena sells earrings from a booth at the arts fair. She pays $200 to rent the booth. She makes $5 from each pair of earrings she sells. Her profit P can be found using the following equation, where N is the number of pair of earrings sold. So here's the equation that we're using, and the question is asking us, how many pairs of earrings must Lena sell to earn a profit of $450? This problem is not difficult if you read carefully, because all you need to do is make sure you substitute correctly. So when they ask us how many pairs of earrings, well, pairs of earrings, according to the problem, was represented by the variable N. Because the problem says how many, that means we don't know what N is. So this part right here is basically telling me find N, find out what N is equal to. And this part right here is telling me that P is equal to 450, because again, just reading the problem carefully, it says her profit P. So it's telling us that the profit is being represented by the variable P, and the question is giving us the profit. So it's basically asking us, find out what N is equal to if P is equal to 450. So if you got that part, now you understand that all we have to do is replace P with 450 in this equation. So we know what the profit is, it's 450. We don't know what N is, right? That's why I said find N. They're asking us how many pairs of earrings. N is the pairs of earrings. So all we have to do is solve this equation for N. I'm going to start by adding 200 to both sides. And I ran out of space, so I'm going to bring my room up here. That's going to give me 650 is equal to 5N. To get N by itself, I just have to do the inverse of what's being done to it. So it's being multiplied by 5. I'm going to divide by 5 on both sides. On the right side, that cancels out and just gives me N. And on the left side, I'm going to get 130. And there is my answer choice right there. Of course, you can always check by substituting the 130 in here for N, multiply by 5, subtract 200, and you will get 450. Given the relation, and they give you the order pairs, what is the sum of all the elements in the range? This is just a vocabulary question. We need to know that range means all possible Y values, or all possible output values. And you need to know that sum means that we are adding things up. If you know those two things, we can answer this question. So all possible Y values. So let's look at the relation that they gave us. The first Y value is 5, the next one is 2, the next one is 1, and the next one is 3. Again, sum means to add, so all I'm doing is adding up. 5 plus 2 plus 1 plus 3, which gives me 11 as my answer here. Number 5, what is the value of x in the equation? I'm going to rewrite the equation just to give me some space to work with. So as we've said previously, when you have equations that have variables on both sides, we should start by getting the variable to one side first. So I can do that by either adding 3x to both sides or subtracting 2x from both sides. I'm going to subtract 2x from both sides, but either way, you'll get the same answer. Negative 3x minus 2x is negative 5x. I'm bringing down that plus 19, bringing down my equal sign. 2x minus 2x cancel out, and I'm bringing down my 106. Now that you have a two-step equation, it's easier to get rid of the number that is the constant, the one that's by itself, now with the variable first. So I'm going to do that by subtracting 19. And of course, whatever I do to one side, I do to the other side. That negative 5x comes down. These cancel out. My equal sign comes down. And if I subtract correctly, I will get 87. X is being multiplied by negative 5 now, right? When there's nothing in between, that means multiplication. So the inverse is to divide by negative 5. Why? Because negative 5 divided by negative 5 will give me 1, and 1 times x is just x. On the right side, I'm doing the same thing. I'm also dividing by negative 5, and if you throw that in your calculator, you will get negative 17.4 as the answer for this equation. Number 6, the square root of 243 minus the square root of 75 equals the square root of n. What is the value of n? So I cannot subtract expressions that have radicals unless they have the same radicand, meaning the number under the radical sign has to be the same, and it's not. So what we have to do is rewrite these radical expressions. So when you simplify radicals, what you're trying to do is rewrite it. So I want to rewrite square root of 243 as the square root of something times the square root of something else. But we want one of these to be a perfect square. So when I talk about perfect squares, I'm talking about numbers whose square root is whole numbers, right? So numbers like 4, because the square root of 4 is 2. So 4 is a perfect square. 9 is a perfect square because the square root of 9 is 3. 16, 25. And you're looking for the biggest number out of all of your perfect squares that can go into 243. And so if you go down your list, you'll realize that 81, which is a perfect square, can go into 243. And it's 81 times 3. So the square root of 243 is the same thing as the square root of 81 times the square root of 3. Now, because the square root of 81 is just the number 9, I can rewrite this as 9 radical 3. So the expression square root of 243 is the same thing as 9 times the square root of 3. You'll see why we're changing it in a second. Now I'm going to do the same thing with the square root of 75. So again, you're looking for the biggest perfect square that goes into 75. Hopefully you see that that is 25. So the square root of 25 times the square root of 3 is the same thing as the square root of 75. But the square root of 25 is just 5. Bring down radical 3, and now I'm going to bring down that minus sign. Now we have the same number inside of that radical sign. And now what you can do is think of it just like you're combining like terms. You would add or subtract the coefficients and keep the variable, right? Same thing's going to happen here. We're going to add or subtract the coefficients. So 9 minus 5, that gives me 4, and we're going to keep what's under the radical sign. So all of that is equal to 4 times the square root of 3. Now, in this problem, they're looking for this to be in the format of something under the square root sign. So I'm going to rewrite this 4 as the square root of 16. Square root of 16 is 4 because 4 times 4 is 16. Bring down this radical 3. So this is the same as the square root of 16 times 3. And 16 times 3 is 48. So n equals 48. Number 7, what is the solution of the system of equations shown below? When you have a system where one of the variables is isolated, and in this case, we actually have both of these variables isolated, the easiest way to solve it is using substitution. So what I would do here is, because I know that y is equal to 2x, right? That's what this equation is saying. That means that wherever I see a y, I can replace it with 2x. So I'm going to rewrite this first equation, y equals 4x minus 10. But instead of writing y, I'm going to write 2x, again, because they are equal to each other. So I'm allowed to do that. Bring down the rest of the equation. And now, again, we're seeing an equation that has variables on both sides. Let's get it to one side by subtracting 4x. I could subtract 2x, but that would leave nothing on the left side, and that wouldn't help me. So I'm going to subtract 4x instead. 2x minus 4x is negative 2x. Bring down your equal sign. Bring down your negative 10. Do not forget that sign in front of it, please. Now we need x by itself. It's being multiplied by negative 2, so we're going to divide by negative 2 on both sides. That's going to cancel these out and give me x equals positive 5. So already we see that our answer choice is probably A, because that's the only one that has a 5 as the x value. But just to be sure, let's find the y value. So to find the y value, you can pick either equation from the beginning of the problem. I'm obviously going to pick the simpler one. And now that we know what x is, let's replace it. So we're going to replace it with 5. bring down the 2 and solve for y. So y equals 5 times 2 is 10. And so there's our answer choice A. In her catering business, Maria prepares and serves Italian food. The amount of lasagna is prepared according to the following table. So it shows you how many guests there are and then how many pans of lasagna have to be made for each of those guests. Based on the pattern in the table, how many pans of lasagna should be prepared for 250 guests? So this is suggesting that we have a proportional relationship, that for whatever number of guests there are, we're always making the same amount of lasagna per guest. So I can take any of these ratios from this table. I'm just going to pick the smallest one. So let's go with the 10 guests to 3 pans of lasagna. And I'm going to write it down as a ratio. So 10 guests require 3 pans of lasagna. And now they want to know, what about 250 guests? So we're going to set up a proportion so that we can find out what the equivalent ratio is. Now, the important thing about proportions is that you put the units in the same place. So if I have guests in the numerator here, I better have guests in the numerator here. This is pans in the denominator. Pans need to go in the denominator. So what did they give me? They gave me the guests and they want to know the pans. So the part I don't know is what I'm going to call a variable. So I'm going to put an X in the denominator because I don't know how many pans. I'm going to put 250 in the numerator because I do know how many guests. Now, to solve this proportion, you can do it a couple different ways. I'll show you 2 ways. If you see that you can divide one number into the other easily, so I know that 10 can go into 250 25 times, so this is times 25. I know that to keep this proportional, I have to do the same thing in the denominator. So I would do times 25, and that would give me that X is equal to 75. So 75 pans of lasagna need to be made if we're going to have 250 guests. The other way to solve proportions is to cross multiply. So we can say 10 times X and 3 times 250, and then we write that as an equation. So let me do this in a different color. 10 times X is equal to, and then 250 times 3 is 750. And now we solve this one-step equation by dividing by 10 on both sides. Divide by 10. That gives me X, divide by 10, that gives me 75. We did the same thing, it just looks different, and either way you do it, you're going to get 75 pans of lasagna for these 250 guests. Mrs. Sanchez writes the following table of X and Y values on the chalkboard and asks the students to find an equation that fits the values in the table. Which of the following equations describes the relationship between X and Y? When you look at the choices you have, hopefully you realize they're all in y equals mx plus b form. So this is telling us that it is a linear equation that's coming from this table. So to write a linear equation in y equals mx plus b, I'm going to need to find out what the m is and what the b is. The m is my slope or my rate of change, and the b is my y-intercept. So let's start by writing down the slope formula. To find the slope, we do y2 minus y1 over x2 minus x1. All these are the y2, y1, x2, x1. Those are just 2 points. So we get to pick any 2 points from the table we want. I'm going to pick the ones that are positive because why not stay away from negative values? So I'm going to use these 2 points here. Let's label them. 2 is going to be my x1. And if 2 is my x1, then its corresponding y value has to be called my y1. The 4 is going to be my x2, so its corresponding y value is going to be my y2. And now we're just going to take these values and substitute them into this formula to find our slope. So our y2 was 6 minus our y1 was 2 over our x2 was 4, our x1 was 2. And now we're simplifying. 6 minus 2 is 4, 4 minus 2 is 2, and 4 divided by 2 is 2. So my slope is 2. So I already know which value should replace m. And actually, if you look at your answer choices, only answer choice A has a slope of 2. See how slope is the number that's before the x? So it's going to be A, but let's just verify and make sure that the y-intercept is actually negative 2. Well, there's a longer way to find the y-intercept, but this problem actually made it pretty easy because if you look at the table, this value right here is special. This ordered pair 0, negative 2 is the y-intercept because at every y-intercept, the x value, is always going to be 0. So if the table gives you an ordered pair with x value 0, you already know the y-intercept is negative 2. And that looks like answer choice A, like we said. All right, last one for this practice session. Lamar works in the quality control section of a toy company. The factory is producing 3,000 steel man action figures. Lamar randomly chooses 120 of them and has examined them for defects. Of these 120, 8 of them had defects. If this ratio held true, so before I go on, I'm going to write that ratio. Any phrase that comes after the word of is always going to be the denominator of your ratio. So we're talking about a total of 120 figures that were examined. Now, of these 120 that were examined, 8 of them had defects. So the 8 is going to go in the numerator. So this is the number of figure that had defects, and the 120 is the number of figures that were examined. Okay? And now it says, if this ratio held true for all 3,000 figures, how many additional figures of the remaining 2,880 would have defects? It's saying the ratio held true, meaning that I'm going to create an equivalent ratio to this. And now we're looking at the remaining 2,880 figures. So that's how many more we're examining. So that should go in the same place as the other examined figures, which is the denominator. So that's going to go down here. And it's saying how many of them would have defects. How many means we don't know, so we use a variable, x. There's x number of figures that have defects out of the remaining 2,880. Just like the other problem, we are solving a proportion, so you can do it 2 different ways. I'll just do it by cross multiplying this time. So we're going to cross multiply 2,880 times 8. That's going to give me 23,040. We're going to bring down the equal sign, and then you're going to cross multiply the other way, 120 times x, which is, of course, just 120x. You're solving a one-step equation, so we want to get that x by itself, so we're going to divide by the 120. That way our x is by itself. But whatever we do on the right, we have to also do on the left. And when we divide by 120 there, we're going to get 192. So 192 figures would have defects out of the ones that are remaining. All right. That's the first 10 problems. I will upload more videos with the remaining problems on this practice test. If this was helpful for you, please don't forget to give the video a thumbs up and consider subscribing to the channel. Thank you, guys.